Thank you so much for joining. So let's get started. Well, in the next about 45 to 50 minutes, I'm going to talk about some really cool things that are relatively new in Java and modern Java. So let's talk a little bit about what Java has been and where it's been, where it's going. And then we'll talk about some very specific features that are available in the case of Java. Well, Java is a language that's been around for, can you even believe it? It's been 25 years since Java was introduced. 25 years, I kind of often wonder, is that human ears or dog ears, if you want to look at it, because languages in general don't last that long. Languages in general are not popular for, more than 10 years or so. Sure, languages get used for a long time, but the popularity of a language diminishes over time. Well, Java is a language that's disproved all those theories. 25 years later, the language is still going strong and it's improving in so many ways. And I'll be absolutely honest about it. I was one of those people on the other side of the picket line constantly complaining that Java is moving too slow, that the development is not fast enough, the language is verbose, the language is, not as exciting as it was once. And all that opinion I had started changing over the past several years, seeing the development behind Java. I have to say that I have the deepest respect for people behind the Java language, the people who are developing the Java language, the JDK and the Java platform every single day. Well, Java is definitely exciting all over again. And to me personally, that excitement started in Java 8 with the introduction of functional style of programming. And of course, with functional style of programming, we have this benefit of not only writing code in the good old imperative and object-oriented style, but also to be able to write the code in functional style as well. One of the reasons that really got me excited was that functional style of programming gives the ability for us to write code in a way that the code begins to read like the problem statement. It has reduced accidental complexity compared to imperative style of programming. So we have this luxury today, or the benefit today, of writing the code using the style we choose to. We can write code in imperative and object-oriented style, or we can write the code using functional and object-oriented style, or mix them all together the way we want to. But it definitely is very exciting time for Java. Now, of course, as we all know, Java is now on a 6 months release cadence. Now, Java 8 took a very long time to develop, and so did Java 9 come afterwards. But starting Java 10, we started seeing a 6 months release cycle of Java. So this is really exciting times for Java because every about 6 months, imagine this is like a train leaving every few months, if you will, every few minutes, if you will, rather. And you have a train leaving every few minutes, and you can get on the next train. Or if you have really busy with the certain things, you can get on the train after that. It's not like waiting for days or weeks or months to get on board. And this really comes to agility of development when it comes to the development of the Java language itself. That's one of the biggest benefits we get out of this particular release cadence. Well, for us, the developers, the benefit though is we don't get this water hose approach where a lot of features are thrown at us in a short amount of time for us to pick up and run. I remember this very clearly, and I might ask you, if I was in an audience where I can interact with people, I typically would ask this question. Java 8, I took the time to learn Java 8. I even wrote a book on the features of functional programming in Java. But I ask developers often, how many of them have used completable future? And to my surprise, not many people have used completable futures compared to people who have used things like Stream API and Lambdas. The point I'm making is that when a particular feature of a language has a lot of features in it, we tend to focus on a few and tend to really leave out the rest. Not because those other features are not important, it's just that they have not gotten the attention, and we can only focus on so many things in one time after all, isn't it? So as a result, features like completable futures, which are actually really important, kind of were pushed by the wayside, and we focused on other features which are probably as important as those features were. Well, with the 6 months release cadence, one of the biggest benefits we get as programmers is we get to take these bite-sized improvements. We get to experiment a small feature and be able to use it. And it's a small feature maybe for us as programmers, but it does take a lot of time and effort to implement correctly in the language. And of course, it can provide enormous benefit over time in terms of how we use it in the language. So small in terms of the number of features, but not in matter of significance by any stretch of imagination. One of the other things I want to really emphasize here is Java is not being developed on a 6 month cycle. Java is being released on a 6 month cycle. So the features that go into Java today are taking the time and effort they need. Some features take, 4 years, 5 years. In fact, if you look at Project Loom, that's been in development for well over 10 years already. So the development time of Java has not reduced. Java is being developed at the same effort and the same time each feature deserve and take. But the release cycle is every 6 months. So when a feature is ready, it doesn't have to wait for the next major release of Java. It can get on the next release train, so to say, and that makes it easier for development, easier for the feedback cycle, easier for adoption, get the feature into the hands of the users, which is where it really belongs, isn't it? Well, in so many words, what I'm describing is agility in software development embraced by the developers behind the Java ecosystem. Well, but we will focus today on a select few features that are in more recent versions of Java. Java 12, 13, 14, 15, and let's take a look at some of the nice features we can benefit from and how really they make not only the Java language a better language, but it also makes us a better programmer using these features as well. A case in point, I was refactoring a piece of code only yesterday, and as I was looking at the piece of code, I was doing a code review, and the programmer had written a multiple series of if-else statements with nested if and else. I'll be honest about it. When I look at a piece of code, I want the code to be inviting. I don't want the code to be pushing me away and saying, go away, I don't want you here. I want a code to be inviting. So when I look at a piece of code, I want to really feel motivated to read. And when I see a nested set of if-else statement, that's a code that pushes me away and says, go away, go do something else. This code is not for you. And the point really is, I looked at this code and said, the code works because the unit tests were passing, but the code was not really in a less complex manner as I would like it to be. And I thought about it for a minute and I said, wait a minute, this developer had written the test for it. The test is passing. What if I refactor it? So I refactored the code to use a switch expression and then see the test actually pass. But the code size shrink in size makes it easier to read, easier to understand. So the point really is we definitely want to move towards better quality code, but a code that's less complex as well. And that's exactly the reason why I'm really motivated by these features of Java. So let's dive in and look at some exciting features. Well, the first one I want to talk about is what I would like to call as smart casting. Well, the developers behind Java call that as a pattern matching with instance of, but this is really one of the nice things in Java. Let's talk about the past Java, how we were doing things in Java before and how things are, maybe different today compared to what we used to do once upon a time. Well, the current Java is a lot elegant compared to the past Java, which is really nice. But it's also important to kind of take a look at where we have been to really, so to say, appreciate where we are today as well. That can be a very remarkable way to give it credit. So let's take a look at a little bit of a past Java and then dive into the current Java, what we can do in the case of Java. So let's start with a little function, if you don't mind. So let's start with a function. Let's call this one as a process function. It takes an object of input, some kind of an input or a message of different type it has to deal with. Now, in this case, I'm going to say if the input is an instance of, let's say, an integer, then I might simply print out, got a number, let's say. Well, okay, that's a good start. What if it's not an integer? Well, if it's not an integer, I might simply say, if it's an instance of a string, I might say got a string like so. So let's start with this little example and see where it takes us. Let's go ahead and call the process function. And to the process function, let's send a 1, if you will, and let's also send maybe a hello like so. So when I run the code here, what you notice is it says got a number. It also says got a string as an output. However, what I would like to do is to display the length of the string we actually got in here. So I could say got a string of length, and then what am I going to say here? Maybe a plus and print out the length that I got. But how do I know what the length is? So in other words, I might go back here and say length is equal to, and I'm going to say input dot length. Now, in this case, when I call the length method, you know that the code will not work. As Java programmers, you know this already. You got an error right there. What does the error tell us? The error says, I cannot find symbol length, but of what? Of type object, it says. So in other words, the compiler says that the object input, reference input of type object, doesn't have a method called length. That's what it says. So how do we really fix it? Well, you know the answer for that too. You would then say string like so, and you would wrap the input around that particular, a reference to the string type, and then you would execute the code, and the compiler is like, okay, the length is fine. Now, what is this called in Java? So in Java, they call it, well, you know the answer for that. They call it casting, but I call it punishment. So if you really think about it, this is punishing the programmers, isn't it? Because this is like working with somebody and you see them, let's say, on the way out the door one evening, and they are, say, where are you going? And they say, I'm going to go watch this amazing movie I haven't had a chance to watch so far. Well, the next morning you see them, and here's the way I hope the conversation doesn't go. You look at them and say, hey, did you go to the movie yesterday? And they say, I did. And then you ask them, how was it? And they look at you and say, how was what? You're probably not going to talk to them for too long after this, isn't it? Because you expect people to have a conversational state. So when you say, did you go to the movie yesterday? They say, I did. And when you say, how was it? You obviously mean the movie, and you want them to say how the movie was. Well, this code behaves like that person. You say, hey, is the input string? And the compiler says, yes, it is. And then you said, get me the length. And it says, length of what? And you're kind of rolling your eyes saying, really, compiler? Are you going to do that to me? Well, the one phrase I often use is, I want to ask the question. So the question I often ask is, do you work for the compiler, or does the compiler work for you? And I always wonder about it when compilers behave that way, right? So do you work for the compiler, or does the compiler work for you? Well, in the past, the Java compiler, we were working for the Java compiler. The Java compiler comes to you and says, how's it going? And you're like, I'm working. And the compiler says, good, keep working. I will check on you after lunch, and goes to lunch. Well, I don't want to work for the compiler. I want the compiler to work for me. I want the compiler to be smart and not really behave like the way it did here. And that's why I'm really interested in a smart instance of. So the smart instance of removes the burden from us to be able to write the code in a better way. And as you can see in this case, we did the casting, but rather than doing the casting like so, let's give it a try slightly differently. We will come down to this code and say stir.length. Of course, you wonder what in the world is stir? Well, you can tell the compiler, hey compiler, go ahead and check if input is an instance of string. And if it is an instance of string, then give me a reference called stir, which is referring to the same instance, but the type of the reference is a string at this point. So as a result, we don't have to waste our time and effort performing the casting. Now, if you're really curious about this, make no mistake, if you ask if input is equal to stir, notice the result is a true because input is really the same reference as a stir is. The only difference is the type of input is object, but the type of stir is a string. But both, if you will, refer to the same instance on the heap or in the memory, let's put it that way, instance in the memory, and that's basically what you're dealing with. So this gives us a nice way to perform a smart casting, as you can see in this particular case, a very nice little feature to use. Not only can you use that in this context, you can also use it in a much more fluent context as well. For example, if I were to go back to this code and say something along the lines of return, and I could say input is an instance of stir, and maybe after this, I can say stir right there, and I could simply say if that were really true, and then stir.length is greater than 4, then I might say something like yes, if you will, or I might say, a no, for example. So you can even use that in such context as well. So in this particular case, obviously, I'm going to be performing the smart casting. So let's go ahead and take the input is of type stir right there. And then we ask if the stir is really an instance of length, if you will. Oh, I'm obviously making a mistake here. Let's see what it's telling us. Illegal start of expression. So I want to return from this, obviously. Let's go ahead and try to put a little bit of this and see why that's not too happy with me. But let's give it a try. Well, okay, I'm going to move on from that one. But essentially, what you can do is you can specify this in an AND context as well. If you were to say instance of string stir, and you can ask a further question about it and say, hey, let me ask if the string is greater than 4. If that were really true, I want to perform the operation further. Otherwise, I can, take another route in the computation and so on, and you can move forward. Now, as I can see here, usually when I'm in front of a live audience, I've got people correcting all my mistakes all over. Here, unfortunately, I have to rely upon my poor self. But as you can see in here, you can make those kinds of computations and perform the return. Obviously, this is a void function, so it's not too happy for my return type. So I'm going to modify this as a string in here. And maybe I can come down here and maybe output the result of this particular operations for us to see. As you can see that that code is going to be now returning a piece of data, and then we can probably take a look at it. Finally, as you can see right there, so you can use that in the context of a conditional as well. And this really begs the question, what is the scope of that variable stir? And the scope of the variable stir is really only in the path where the input is considered to be a string. So in the context of the if you saw earlier, that stir variable is only available within the block of the if. And so the scope is fairly limited in terms of where we can use it. And that's basically the smart casting feature. Like I said, I'm a huge fan of this particular feature. It really makes me feel like I am working with the language that is having a nice conversation with me like a mature adult, rather than telling me to do mundane stuff. Well, we looked at the smart casting. Now, that is one welcome feature. but I'm also really eager to where it's going to go in the future in terms of more power to pattern matching that we are going to see along the way. Well, that's great so far, but let's go a little further with this. We're going to talk about switch expression. This is one of my most new favorites in the language. In the past, switches were statements. I am not a fan of statements at all. So statement, if you think about a statement versus, let's say, expression, well, it turns out in a purely functional programming language, you only have expressions and you don't really have statements. But why is that? Well, because statements cause or force side effect or mutability. So in other words, if you're using a statement, the statement is going to force you to perform an action and modify a state or cause a side effect, whereas expression nicely return data back to you. So in that regard, expressions make for a much more pleasant experience in programming. They reduce error. But switch was a statement in the past, and it still is, but it's also an expression when it comes to the modern Java. So switch, you can have switch as a statement and as an expression. You can use them either way. Of course, my preference, you kind of guess it, is going to be use it as an expression rather than a statement. One of the things I was not also a fan of switch statements were that you had to put that silly break in every case. And if you don't, it ends up executing the next case. Well, that's not the case with expressions, of course, because every case will become a different path to take automatically, which is really nice. And I'm a huge fan of that. So let's talk about switch expression and how we can benefit from such a switch expression in here. Let's start with a little example, if you will. Let's start with a java.time.star, but let's also bring in java.util.stream.star as well. Let's start with a little example. So I'm going to say stream of and day of week. So we'll take every day of the week that is given to us and we'll do a values of. And in this case, we'll say for each. And what am I going to do with the day of week? So given a day of week, what I would like to do is to pass that to a function that's going to perform some processing for an activity, if you will. So let's go ahead and output right now. And what am I going to output? I'm going to output the day of week plus, let's go ahead and say in this case, I want to output a colon, and then we'll say activity. So activity, and pass to the activity the day of week. So let's start with baby steps, if you will. So let's start with a little function static, let's say a string, we'll call it activity, which is going to take a day of week as a parameter. And let's go ahead and say in this case, return, we'll come back and return something in just about a minute. So we'll start with each of the days of the week, Monday through Saturday. What do we want to do? Well, I want to take some different actions for each of the days in the week. So notice I can say return, and I'm going to say switch right there, and I'm going to take the day of week. And this was one thing that made me really happy. I can put a return in front of the switch. That is because a switch is now an expression, and I can return values, or I can take a value returned by a switch and assign to a variable or pass it to other functions and so on. But what am I going to do within this? Well, within the switch function, I'm going to say default. And what do I want to do for default? I'll say no clue. I don't know what I'm going to do for that particular day. So we'll return a no clue for that day. So notice it gave us no clue for all the days of the week. But let's start with the case of a Saturday or a Sunday. So notice how I can give two options. And what do I plan to do on a Saturday or Sunday? I know this is really difficult for a lot of programmers, but to take it easy, right? So we're going to take it easy on a Saturday or a Sunday. So when I run the code, you can see it says, take it easy for a Saturday and Sunday in the bottom, and everything else still is no clue. And I know you're thinking, just leave it like that for now. The rest of the days are weekdays. We can come back to that later. Let's take a Monday or a Wednesday, if you will. And what am I going to do on those 2 days of the week? Maybe we'll go to a music lesson on those 2 days. What a nice way to spend those 2 days. We can take a music lesson on Monday and on Wednesday. Well, what about Tuesdays and Thursdays? So we can say here's a Tuesday, and of course I'm going to also come up with the Thursday as well. And those 2 days, oh, maybe we want to do some more work. So let's come back to doing a bit more work for those 2 days. And then finally, we could simply say, here is a Friday. And what do I want to do on a Friday? Oh, maybe for a Friday, we will go to the movies and enjoy some movies on a Friday. That's a good way to spend the day. But what about this Tuesday and Thursday? Maybe on a Tuesday and Thursday, I really want to do some more extra effort in what I'm going to do. So you can put a little curly brace right there. And you can say, in this case, we'll take upon a sport for those 2 days. And what kind of sport do I want to do? If the day of the week is going to be day of the week dot, let's say Tuesday, then maybe I'm going to play tennis. And if it is not, maybe I'll go ahead and play soccer on that particular day. Now I can simply do a yield, and I can say a play, and then specify what I would like to play, the sport, of course. And so as a result, we can say on Tuesday we play tennis, on Thursday we play soccer. And of course, because we covered all the possible values, we don't have to put a default in here, as you can see. What if I don't put a case for Friday? What do? Notice the compiler is smart enough to say, hey, you're not covering all possibilities. What's up with you? On the other hand, if you put a case of Friday, then you're covering all the possibilities in the enum. And as a result, the compiler is quite happy with this, as you can see. So that is an example of a switch expression. And I have to say, this is one of the new things that I've come across in Java that I really like a lot. I've used this feature in other languages, and I'm so happy that I could use this in Java today. And that is basically a switch expression. So the switch expressions enjoy an automatic break, as you can see. You can have multiple matches as well. You saw me put multiple matches right there, or you can put just one, like so, like Friday, or you can put more than one, as you saw right there. You can also have multiple cases as well, as we saw in here. And of course, you can put a lot more code into processing. If that is something you need to do, you can do that quite effectively as well. Now, of course, you don't have to really store this into a variable as you would expect. You could have really minimized that call by simply using the sport right there. So with the plus, you could have simply said, if the day of the week is, give me tennis, otherwise give me soccer, and you can write the code using that particular expression as well. So in this case, obviously, you could provide for and remove that need for an extra variable that you would otherwise create. So absolutely, you can do such things as well where that really makes sense. So that gives us an idea about the switch expression, and how we can benefit from that. Well, the next thing I'm going to talk about, this is what beauty of Java is. There are so many exciting features now that we can actually make use of. One of them to me is the text block. Before I talk about text blocks, I want to take a detour and talk about the innovation in Java. Now, you may say, innovation in Java, what does Java do different? What does Java do new? And I often have developers tell me, oh, this is a feature in Java from, and fill in the name of the language you want to fill in. But I beg to differ. I see innovation in Java very differently than what others may see it as. To me, innovation in Java is not in introducing new features of the language. No. Part of the reason for that is Java doesn't have the luxury that some of the other languages have, wherein they can introduce a feature and then come back and remove it or drastically change it. Well, part of the reason for that is Java is a language used by more than 10 million programmers. You see, when 10 million programmers use your language, and out of which 1 million programmers know where you live, you have to make decisions very differently. So the point really is Java's innovation is not in identifying language features. Java's innovation is in the implementation of the features. I'm going to make 2 points to justify that statement. The first is look at lambdas. Clearly, we know Java is not the first language to introduce lambdas. I often jokingly say that Java came late to the party, but they came with some really good desserts along the way. So Java did not introduce lambdas. It has been around for a long time. But the merit of Java is how they introduce lambdas by using invoke dynamic and using the functional interfaces. That paved the way for benefits of backward compatibility, but also avoiding anonymous inner classes, huge impact on performance, and how a lot of languages are on the JVM are benefiting from lambdas the way they are implemented. Similarly, text blocks are not new in programming. Text blocks have been around for a long time in other languages. Some languages call them as here docs, if you will. And I've seen and I've used here docs in a lot of languages before. But I do have to admit, it is annoying sometimes when languages use here docs in a way that it is hard to use from a programmer point of view. This is again where the innovation of Java is. Java has found a way to implement text blocks in a rather nice and elegant way that makes me really happy as a user of text blocks. Well, in the past, of course, we did not have text blocks, and almost everybody has done this, isn't it? We all have written code, something along the lines of message is equal to, this is first line of a message, and then we come back and say message plus equal to, this is the second line, for example. Then we would come back and say message plus equal to, this is the third line. And do you ever put in on your resume, have you ever said this on your resume, I am really good at using plus equal to string all these strings together? No, this code is very inhumane. This is the code you hide from the world. If you're programming at home, a child walks in, you close the monitor right away because we are so ashamed for others to see code like this. The children would never want to take after a profession if they see code like this, which is verbose and smelly. So this is the kind of code we hide from the world and never put on our resume. But the point really is, it doesn't have to be like that. So if you really want a multi-line string, you can create a multi-line string very easily. So let's take a look at an example of how we would go about doing it. So I want to create a little example here. And the example I want to create here for the multi-line string is going to be something that takes a message and passes it down to the output or console in this particular case. So I'm going to start with a little example, and the example I'm going to start with is called, let's call it as create message. So what does a create message actually do? Let's go ahead and say, I want to send a little message over here, and I want to put a beautiful city of Lviv, and let's go ahead and start with that, and eventually we will, bring it back into life with the name we can use eventually. So let's write a function right here, a string, and let's call a create message a string, let's say a city. And what do I want to do in here? I'm going to create a message first of all, and when I'm done with it, I'm going to return the message. Like I said, we'll come back and make some changes to this along the way. But I'm going to put 3 double quotes to begin with, as you can see. So that gives us a nice text block that we can use. And we can say hello there. And what am I going to say? I hope all of you are doing well and let's say staying safe. It is a pleasure to meet you. That's all we can do right now. And hope to see you in person soon. How about that? So that's basically a little message I want to post over there, and I'm going to put a little love at the very end. So that's a multi-line string that we have created. But one of the beautiful things of this particular code is, if you noticed over here, we started with the message hello there, and I'm going to go ahead and put that little message and execute it. I want you to notice the output really carefully. There is no indentation on the left side. So we created a message, of course, and I'm going to also go back and say, it is a pleasure to e-meet you. And I'm going to put that into a double quote, e-meet now. And in this case, of course, I embedded a double quoted string inside of that. I did not have to waste my time and effort escaping that particular double quoted string. Life becomes really easy, as you can see. But one of the nice things about the text block is it also has smart indentation. And what I mean by the smart indentation is the compiler knows that we probably did not mean for that to be an indentation. That indentation typically is a consequence of putting this code within a function. To illustrate the point, if I were to take this, I hope, and indent it right there, when I run the code, you can see the indentation of I hope compared to the hello H and the I in the it. So you can see the indentation being really smart, as you can see. That's another thing I love about what they have done in Java is that smart indentation. Now, of course, you can also notice that it ignores the trailing spaces. So if I go back to the code right here and I put a few spaces right in there after the word safe, you might be copying and pasting a HTML document or an XML document or a JSON document. And when you copy and paste it, you don't really mean for all those extra spaces to be really used. Well, you don't have to worry about it. When you run the code, those spaces were stripped out. And of course, you say, really? We cannot see the space anyways. Okay, a fair point. So if you really want to see the space, why don't we try something a little different? Let's go over here and say message dot, let's say replace all. And in this case, I'm going to ask it to replace a space with a tilde so we can actually see that while we are executing the code. So you can see the tilde up here, but notice there is no tilde after the dot after the safe because that space was actually removed even though it is here. And you say, okay, great so far, but what if I really want to preserve that space? What should I do? If you really want to preserve that space, you can tell the compiler to preserve that space. And now you can see the tilde at the end of the safe dot, and you can see that appear right there. So that shows you how you can ask it to preserve those spaces where you need to. And similarly, if you want that to be a multi-line string, you can also use a slash. Notice the line between I hope and it is, there is no line between them. If I go back to the code and remove the slash, you can see a blank line between them as well. So you can use that kind of notation to provide some special formatting. Of course, you can use a replace. You saw me do that right now, a replace or a replace all. But you can also use a formatted as well. For example, I can go back to this code right here, and I can say over here, a string.format. And what am I going to format it based on? Take the message that we have at our hands, and I want to format the message. But what do I want to format the message with? I want to format the message with the name of the city that we have received so far. Now, in this case, it says hello there, but I'm going to go back over here and replace this with the %s, if you will. And then, of course, you can see it says hello, Lviv, and then you get to see the rest of the text over there. So that can be a nice way to substitute. Now, sometimes people ask me, is there a string interpolation? And the answer is not at the time, but you don't really have to worry so much about it because it's not that much effort, as you can see, to perform a replacement. And very nicely, you can do a %d, %g, and all those things we normally do in formatting. You can use them here really nicely as well, as you can see. So that is about the text blocks and how powerful text blocks really are. Well, that brings us to two more things that I would like to talk about before we call this done. So the next one is records. So what are really records? Well, we all have written verbose code in the past. We shrug our shoulders and we say that's life in the big city, and we often just get going writing all that code. But thankfully, we don't have to endure that pain. Let's take a look at two examples to illustrate this particular point. The first example that I want to show you here is a class called person that I'm going to create. Now, within the class person, what am I going to do? Well, I'm going to say person is equal to new person. Let's say Alan and Turing right there. And I want to output the person when we are done. Now, how do I implement this code? I would say a private string, for example, and then first name and a private, let's say, a string. What do I want to say? Last name, obviously, I want to write right there. And then, of course, I would then create, oops, let me try this again. So a private, of course. And then, of course, I would create a getter or a constructor, first of all. So we would say a public person. And what do you then do? A string the first name, a comma, a string last name. And then painstakingly, we would say first name. Well, of course, this dot first name is equal to first name. This dot last name is equal to last name. You're not done, right? Then you say public, if you will, a string, get name. And then what do? Return first name. Then, of course, you say public string, well, in this case, get last name. And what do we then do? We say return, in this case, of course, the last name that we want to return. You may protest and say, oh, come on, Venkat, I don't actually write those functions. I define the field. Then I gently right-click on the field. And before I could blink my eyes, my IDE vomits the rest of the code for me. Well, unfortunately, that's an unerasable vomit. And you live with that vomit forever, marching over that code. What a noise and smell you have to deal with every single day. But in spite of all of that, we still don't have a good solution. And look what it printed. That is insult to the programmers, because we are forced to write so much code for no good reason. So this is where the languages that support data classes come into picture. What are data classes? Data classes are called as records in Java. Records or data classes are really objects that do not have any behavior. They simply carry some data. So what you can do here is you can get rid of most of these things. And you can come down to the class here and change it to a record. And you can then say you have a class called person, where the class person, if you will, is going to contain a variable, which is a string to begin. Also contains a variable, which is a last name, if you will. So notice now, I have a elegant record called person. As a bonus, when you use a record, it offers a buy one get 5 free offer. You got a constructor, you got getters given to you, you got a toString method, an equals method, and a hash code method, all that given to us very nicely, so we don't have to really endure the pain of writing a lot of code. Let's look at one other example just to illustrate this particular point. So what I'm going to show you here is a location where I'll say location 1 is equal to, and in this case, we'll say new location of, I don't know, 121.335, comma, let's say minus 70, 80, let's say 74.21. I don't know, it might be a federal prison someplace. Then I'm going to say location 2 and a 3. But for the third one, let's change it to 111 and let's change it to a 94, for example. But what in the world is a location? A record location is going to take a double lat and a double lon as two different values, as you can see. So in this case, I'm going to start out first of all outputting location 1, and you can see the location 1 comes with those values as such. But I can also do a couple of different things. I can take a lat as a property and I can invoke it, or I can open up a lon as a property and display it as well. But more important, I can also simply display a lon as well to you make use of the toString method. Not only that, I can take the lon location 1 and I can ask if it is equals to location 2, and you can see that the result of this operation versus when I ask for a location 3 is a true and a false, and the reason is the equals method kicks in, and if the property values are the same, then those values are considered to be equal for the object. Those properties are immutable. You cannot modify them as well. And as well, you can do one more thing. You can also write a canonical constructor. And in this case, you can say, for example, if, for instance, a math.absolute value of lat, let's say, is greater than, it's a latitude. So we can say is greater than, whatever the value is. I can't keep this in my mind when I'm typing 180 or 90 or whatever that you may want to ask for. And you can say if the value is more than that, you can say throw new runtime exception. And you can pretty much say, whatever exception you want to create. Out of that, you can do that as well. And so if you were to give an incorrect value, then of course you would see that it's going to blow up and give you an exception. And you can work with that too pretty nicely. So what are the benefits of this? You got immutable values on your hand. You can see the properties are provided. The toString is available. Records implement a record interface, but you cannot really extend it further. So they are final, and as a result, you cannot extend from records. You can, of course, implement interfaces if you really want to, and you can add methods too if you really want to add methods. Records can also be local within your functions as well. So this nicely compensates for lack of tuples in Java. So you can define a record within a function, and then you can use it right away. That can make the code very expressive. And one other benefit of records that we're going to see eventually is the records will play a very important role when it comes to pattern matching. And I'm really looking forward to the day when we can do something like in a switch situation. You can do a case. Again, take this with a grain of salt. You can say lat comma lon, and if the object were a record, it would extract, and this is called destructuring or deconstruction, if you will, where using a pattern matching syntax, you can extract the lat and lon very nicely. I cannot wait for the day when we will be able to do something like that. Well, to wrap up this discussion, I want to come up with the last example here to represent the sealed classes and interfaces. So what are really sealed classes? Well, when you create a hierarchy of classes, in the past, we have had the ability to create abstract base classes, can have zero direct instances, right? Instances, but can have any number of subclasses. On the other hand, final classes can't have any subclasses, but can have any number of instances depending on the scenario. So abstract classes can have can have any number of subclasses, right? On the other hand, final classes cannot have any subclasses. What if you want something in the middle? So what does that mean? So a class or an interface with restricted number, subclasses, let's say. So in other words, you want to say what subclasses can be part of your hierarchy. You want to closely monitor and control your hierarchy. Now the question is, why would we want to do this? This goes to what is called an abstract data type. Abstract data types, algebraic data types Algebraic data types give us the ability to control the hierarchy of a set of classes. For example, you might define a set of known dog breeds known to humans. And you can say you cannot have anything more because these are the only possibilities. You can define dice as only those values, or you can define a deck of cards as only those specific types of cards that you can have. So this is where you can use a sealed class or a sealed interface to do it. So I'm going to show you two different examples of doing this. The first is I'm going to go ahead and create a file called trafficlight.java. So the trafficlight.java, what is it going to contain? I'm going to say sealed interface called trafficlight. And the sealed interface trafficlight contains the word sealed to convey the fact that you're going to control the hierarchy. So then I say final class called red light. So the red light implements, in this case, the traffic light. And I'm going to implement two more in here. The yellow light and, of course, the green light as well that I'm going to implement. So you can see that I created a sealed interface. You can create a sealed interface or a sealed class. But then I defined three different classes over here. Now I'm going to go to the sample.java and I'm going to say over here something along the lines of, let's keep it extremely simple. Let's go ahead and say a traffic light is a traffic light, let's say traffic light is equal to new red light, let's say. And I'm going to output okay to say the compiler was okay with me doing so. So the compiler was happy, as you can see. But if I go over here and say class broken light implements, let's say implements, traffic light, as I see sometimes in places around where there's a broken light. Notice the compiler is not happy with me. What does it say? Class is not allowed to extend sealed class traffic light. It's a sealed class even though it's an interface. Well, as you can see, that's not allowed. I got a slap on my wrist. Why is that? Because that particular class is not within the confines of what I'm permitted. So in other words, as a default, a sealed class or an interface can have members all defined within the same file. Good news, that's easy. Bad news, that's too restrictive. So what if you don't want to be restricted like so? Then you can use what's called a permits. So what you could do potentially here is you can say over here permits, and you can provide a list in here, a red light, a yellow light, if you will, and then finally you can create also a green light as values that are permitted like so. But then what you can also do is after you put the permits, you can also add another one if you really want to. We'll come back to that in just a minute. So if I go back to this code, that code will still not compile because the broken light is not allowed. But wait a minute though, in traffic light, it is not happy with the permits that I say expected permits. It says preview language feature recompile with the excellent preview for details. Okay, so it's a preview feature, so I have to add that to the preview in this particular case. Then it would permit me to use it. I got to add that in the compiler flag. However, one of the benefits of doing this approach is if I want to take, let's say, a flashing light, if you will, then potentially what I could do is I can go to the traffic light and I can add in here the flashing light to this mix. And if I were to do that, it will permit me to have flashing lights as a subclass or an implementation of traffic light, even though it is in another file, as long as it's in the same module. So that gives me an opportunity to control the hierarchy. One other place where this will be really beneficial is in the switch. So you saw this earlier in the switch expression. If I did not have a case for one of the options, I got an error. Well, here's the beauty. The compiler can verify and tell you, hey, there is this particular value that is part of the sealed hierarchy. You have not considered it and will give you an error. Or if you have considered all possibilities, it'll keep quiet. And if the hierarchy were to change in the future, your compiler will tell you that you got something missing as well. And that is one of the most recent additions to the language, as you can see. So we talked about a number of features in modern Java, pretty exciting features, as you can see. I hope you're as excited about this as I am. I want to thank you so much for taking the time to be here as part of this session. Hope you enjoyed the conference. Thank you so much for joining. I'll spend a few minutes on Q&A in another channel, and I hope that you will be able to join there for a good discussion. Once again, thank you, and please stay safe.